Hello to you, Tenfolders. Welcome to another epic edition of your favorite television program, Tenfold Live. My name is Sibusiso, and as always, I'm very excited to be with you on another edition of a show that is proudly brought to us with lots of love by Liberty. A very special shout out always goes out to Liberty, who are not only sponsoring this program, but they're also behind our awesome app. If you haven't done so, please go to your App Store and download this awesome app. It's called the Tenfold Education app, and it's packed with a lot of very useful resources for anybody who's doing grade 10, 11, or 12 mathematics and sciences. I promise you, you will actually find very useful resources that you can use to beef yourself up as you're preparing for the end of the year exams. Remember, if you enjoy watching videos and you find a lot of education when you're watching videos, we have a lot of them. We've done them and we uploaded them on YouTube. Please go there and find us. You will search for the Tenfold, not the Tenfold, but the Mindset Learn. We are actually the Mindset Learn on YouTube, so do make sure that you go there, you subscribe to that particular channel, and you also like all the videos that we have uploaded. We've uploaded a lot of videos, including our past shows that we've done before, to help you to actually prepare yourself for the end of the year exams. On today's program, we're looking at the misconceptions and errors that matrics are likely to make. This is actually the first of its kind. It's a show that is specifically orientated around helping you to identify, first of all, the errors that you might make, and also help you understand how do you actually just prepare yourself to make sure that you don't make the same mistake. So it's errors and misconceptions that are made by matrics of the previous years. We want you to be aware of them and want to help you understand how do you work with those kinds of problems to make sure that you don't make the same errors. Okay. So if you look here on my first slide here, the very first thing that I want to draw your attention to is the general errors and misconceptions. Of course, we're going to look exactly at the errors that you're likely to make in paper one. But before we dive into the topics of paper one, I want to just highlight that these are the three popular errors and misconceptions that we see across all papers. Number one is not knowing your basics. So I don't know about you guys, but there is no way that you should be attempting to write your final exam if you have challenges with the concepts that are in your paper one exam. Of course, you know we've got algebra, patterns, functions, finance, calculus, as well as probability and counting methods. So you have to make sure, first of all, that you understand what the basics are in those topics, and you understand how to work with those sections. The second challenge is not analyzing and updating your diagram. I think there is always a love letter that is given to you that goes hand in hand with a diagram. I think in paper one, it is in functions more often than not. And also when you're doing calculus, there's also a diagram sometimes that you get that has an opening statement, which I call the love letter. So you have to make sure that you analyze that love letter against the diagram, and you make any additional updates on the diagram based on the story that is going on. There's a high chance that you struggle to answer a question because you did not read the love letter, and that little single thing that can help you to answer the question lies in the opening statement. So you must highlight the information that you are given whenever you find keywords or things that mean something to you, and you have to make sure that you make an update to try and just help yourself understand what that means and how that can help you to be able to answer your question. So the last thing is, you guys always make calculation errors. These calculation errors that I'm talking about include maybe you missed a sign. I don't know, but I'm sure maybe in your life, ever since you started doing mathematics from grade 8, you've made sign errors at some point and you lose marks because you made a sign error, or maybe, I don't know, like you left out a number or a term or a factor. Okay, so we need you guys to understand that this also contributes significantly to people not getting the correct answers because they left out a number somewhere. So we want you to be able to make sure that you do calculations properly. You don't make calculation errors, either algebraically, or you're leaving out a sign, or you're forgetting a number, or anything of that sort. So just be careful of that. Okay. like I have alluded in paper 1, these are the topics that you obviously generally have in your exam, right? And we want to see what the common exam mistakes are that the matrics always make. We want to help you not to make the same mistakes. So the first topic is obviously going to be algebra with all its subtopics. We will look at them closely, and then we will have sequences and series, and then there's also functions and inverses. After that, you generally find finance, growth, and decay. There is also differential calculus, and then in closing, there is always probability and counting principles. Okay, so let's jump right into our very first topic. So in algebra, generally speaking, the ideas that we want to see that you are aware of, or the concepts that we generally test, include your ability to solve quadratic equations. And then we'll talk about quadratic inequalities, and there's also surds as well as exponents, and we want to know if you can be able to find the solutions to the equations that we give you. And then obviously we also want to know, can you simplify surds and exponent expressions? So and then we also have simultaneous equations that we also examine, and there's also nature of rules, and then maybe in closing there's other things that we may include in your question 1 or your questions that revolve around algebra. So those might include like some interesting, weird kind of like questions that we ask to see, are you able to analyze a problem and use all the skills that you have learned of equations, exponents, and surds to try and figure out the solution to the problem. Now, if you just zoom on equations that are quadratic equations, there are 2 things that I want you to know. Of course, some quadratic equations can be solved by factorization, okay? You might need to factorize in order to find a solution, and some might require you to use the quadratic formula. And I think we all know what the quadratic formula looks like because we have seen it, and it's also given in our formula sheet. Now, before we go far, I just want to say, for example, suppose you had the following 4 questions, because these are the errors that we generally see when you have something such as x squared minus x equal to 0. And you're asked to solve an equation like that one. What do you need to do, and what are the general errors that we see? Okay, and the second one could be when you have x squared minus 1 equals to 0. The third one, I want us to look at an equation such as x minus 3 with x plus 1 equals to 0. And lastly, which is my favorite, is when you have the same thing, x minus 3 multiplied with x plus 1 is equal to not 0 this time, but equal to 7. Now, the very first equation that you're looking at, the x squared minus x, the mistake you can do, this is what we generally see people do. Like, people will say, okay, just have x squared and then add x on both sides of the equation. You guys call it transposing, which is wrong. Okay, moving x to the right, that's not what you're doing. You're just adding x on both sides. And then you would divide both sides by x, and then you'll end up with x is equal to 1. So this is actually wrong. We don't want you to do this, okay? What we want you to do is, which is what you should be doing, is acknowledge the fact that you should get 2 answers. Excuse me. So you need to get 2 answers, and that is possible if you take out a common factor, and then your first x value is going to be x is 0 or x is equals to 1. So what am I saying here? The general problem that we've seen before is people dividing by a function such as x. Okay, so please be careful. You are not allowed to do that. If you do that, you're going to lose one of the solutions or one of the answers. You're only going to get x is 1 and you lose the second answer. So please don't do that. All right, so in the second equation, generally what we see is people will just add 1 on both sides, and then you want to remove the square, so you square root on both sides, and then you end up with an answer that says x equals to 1. Like I said before, this is quadratic, so we're expecting not 1 but 2 answers, okay? We want to see 2 solutions, right? So this will be a mistake. What you have to do is you have to, of course, take the x squared. You can add 1 on both sides, but when you take the square root, you have to remember that the 1 on the right hand side is not only the only solution, but you have to have plus minus that. So we need to plus minus here on the right hand side. So the square root of 1 is 1. So your answer should be plus or minus 1. Now when you look at these two equations, they look very similar. Okay, they are close to almost the same. So when people see this kind of question, what we've noticed is that what you guys do is you want to break these brackets down by applying the distributive law, which is not necessary. So I want you to draw your attention to the following. This is not necessary, because what you're going to do is you're going to have x squared minus 3x, okay, I think it's plus x, and then minus 3 equals to 0. Now you must add the like terms, and then you have to, I don't know, you have to also, after doing this, you have to try and add the like terms and factorize. This is not necessary. Please do not do this. It's a common error that we see all the time. What are you supposed to do here? Well, what you're supposed to do is acknowledge the fact that this is a product of two things. So when two things are multiplied and the answer happens to be 0, it implies that either the first one is 0, okay, or the second one is 0, okay. X plus 1 is 0, or x minus 3 is equal to 0. So this is what the zero factor law says. So you're going to have x is 3 or x equals to negative 1. Now on the last one, we have x minus 3 and x plus 1 equals to 7. Can we apply the same idea as the one that we had over here? And the answer is no, you can't do that. That is not allowed. Why is this not allowed? Well, because we have a product that leads to an answer of 7. Only if the product leads to an answer of 0 can you say the first root or the first factor is 0 or the second factor is equal to 0. In this context, unfortunately, you will have to do this whole distribution, and then you will have x squared. From this, you'll have minus 3x plus 1, which is going to leave you 2 minus 2x. And then you are going to have minus 3, and then this is going to be equal to 7, okay? This is what you're supposed to do. The mistake that you can do here is if you do the following. It will be wrong for you to say x minus 3 equals to 7, or x plus 1 equals to 7. So this would be a big mistake. Please do not do this. It's not allowed. The zero factor law only works if your answer is equal to 0. So please be careful of that, okay? You have to then do this, and then you'll do what I would like to call adding like terms. You'll have the following, and then you'll have 10, and then you can finish it off to get your answer. All right. Now, maybe perhaps from this question, I might just highlight that it will require you to use the quadratic formula to solve x squared minus 2x minus 10. Now, everybody is familiar with the fact that x is negative b plus minus the square root of b squared minus 4ac, okay, divided by 2a. So what is the general problem that we see, or the mistake that we see, or the error that we see, is that you guys do not substitute this correctly in the quadratic formula. If I wrote minus 2, because my b is 2 here, okay, plus minus the square root of minus 2 squared minus 4ac, okay, my a is equal to 1, and my c is equal to negative 10, and I divide all of that by 2 times a, and my a is 1, right? So you will notice that there's a mistake here, and there's also a mistake here, or the minus 2 squared. What's the first mistake on the first term? Where you did not put the minus sign outside. Remember, the formula also has a minus sign. So you have not written this minus. I don't know that minus I'm seeing here. Is that the minus of the number b, or is that the minus of the formula? Okay, the formula has a minus. Even my b term, in this case, also has a minus. So the correct way would be to have negative, open bracket, negative 2 plus minus the square root, in brackets, negative 2 squared minus 4 times 1 times 10, and then divided by 2 times 1. So this is another popular mistake that we've noticed, and we want you guys to be aware of that. Please don't make mistakes when you are dealing with that particular section. And then maybe when you get an answer, I think from this particular question, if you solved it further, you will get that x is equal to 4,63166. Another x solution would be equal to negative 2, 3166. So when we ask you to round off to 2 decimal places, apparently some metrics do not know how to round off. In this case, it has to be 4,32. So you must know that we actually take this very, very serious. And the other solution is going to be negative 2,32. So rounding off is also another error that we see a lot. So please go back and revise your skills of rounding off when you're dealing with questions that leave you with answers that are irrational. Right. Now, quadratic inequalities. What are the challenges that we see in quadratic inequalities quickly? Well, number one is that you guys treat quadratic inequalities as equations. Now, assume that I had a question that was saying negative x squared, and then it had minus 2x, and there was plus, I think, 15 here, and then it says greater or equal to 0. Now, the very first thing to do will be to divide by negative. So please be aware. If you want to divide this by negative, all the signs will change, but the inequality also needs to change. So be careful of that. It has to change direction, and it's going to face the other way because you are dividing by a negative in your attempt to remove that negative sign. And then you're going to find the solutions by factoring this. I think we're going to get x, I think it's plus 5 and minus 3. Okay, it's less than or equal to 0. So one of the common errors is that people will normally do this, which is wrong. You can't say x plus 5 is less or equal to 0 or x minus 3 is less than or equal to 0. This is wrong. This is actually a very wrong way of looking at it. It's a common mistake. Don't do it. What you have to do here is apply your knowledge of solving inequalities, which means that we want you to take what is called the critical values, okay, which will be x equals negative 5, and the other one will be x equals to 3, but then the solution is going to come from you drawing a graph which cuts x at negative 5 and 3, and because we're looking at the parts where the graph is negative, we want this part over here, and that part lies between the x value 3 and the x value negative 5. So you have to know how to put your inequalities so that you don't make a mistake of treating your inequality as an equation. It's a popular mistake we've seen a lot, so please do not make that mistake. Now, very close to closing now, the next one is when you're dealing with surds. What happens generally when you're dealing with sets is if you have a question such as the square root of x take away 1 added with 3 equals to x, it is wrong to square each term individually like this. Okay, this is a misconception. Your brain tells you that you need to get rid of the square root by squaring on both sides. Not every time. This will be a mistake. What you have to do is, first of all, isolate the surds. So this is the correct way of looking at this, okay? So you're going to treat your x minus 1, and then you're going to subtract 3 on both sides. You'll get the square root of x minus 1 equals to x minus 3. Now, you then square here once, and then square here twice. On both sides of the equation, this is going to give you an answer of x minus 1. And then here's another problem that you can make here. People don't know how to square a binomial. This is not going to be x squared plus 9 because you are literally squaring the x and then squaring the 3. Please do not do this. It's a very common error. What we actually want you to do is make 2 of those babies. The x minus 3 must appear twice, and then you're going to do foiling business, and then you're going to get your answer, and then you're going to get whatever you need to get there. Now remember, you have to, after you've done everything, after you have to check your solutions. This is another popular error we see. People don't check if the answers that they're getting are correct. And I can tell you now, on the one that I'm looking at here, if you solve it, you'll get that x should be 5 or x should be 2. And in both of them, the 1, 5 value is correct, but the 2 answer is not going to be a solution because it does not satisfy the original equation. So please do make sure that you check your solutions after finding them here. Okay, now in closing, we've got simultaneous equations, and then in simultaneous equations, okay, of course in exponents, that's the same idea that we're actually dealing with, which is involving what do you do when you're squaring binomials. I will repeat again. If you have a plus b and it's squared, it's not equals to a squared plus b squared. Instead, what you need to do is make 2 of them, because we see this almost all the time. And then you'll get a squared plus ab plus another ab plus b squared, which leads you to a trinomial that looks exactly like what I have here. And then you can be able to solve your question. And this is an error that pops up almost everywhere, because you guys always find yourselves in a position where you have to square a binomial. So please be careful of that. Okay, now in simultaneous equations, what are the general errors that we see? Well, simultaneous equations is going to be the first equation, okay, equation 1, okay, let's call it just equation 1, and then there's going to be another equation, which is equation 2. Now, generally speaking, if you had an equation that says 2x plus y equals to 7, and you had an equation that says 4x squared plus 4xy minus 7 equals to 3x, maybe 3x, something like this. You know for a fact that it's best to make y the subject of the formula here, so you have 7 minus 2x. Now you want to replace your y with this. And where does y appear? Y appears right over there, okay? It's not bad if this is actually the case, okay? It's not bad. Just remember that there's also a 4x here that needs to multiply all the terms that you have over there. But if you have a question that was the other way around, let's suppose that we didn't have y where y is, but we had x instead, you would have a situation where you have x here, and then we have, okay, wait, let's say you have y here, okay, and then you have x here. Then that implies that you would have, in this particular part, x as the subject of the formula, and this y value will be what you have over here. Okay, because I want you to see something very interesting. You'll have x equals to 7 minus 2y. Now, if you try to sub this x is 7 minus 2y in your equation, what you guys forget is that you have 4x squared plus 4. Now there's x, so your x becomes 7 minus 2y, and then you've got y here minus 7, and then equals to whatever the case might be. Now the mistake generally happens here. Okay, this is where the error occurs. Remember, you are not only multiplying 4 in the bracket, but you're also multiplying 4 in the bracket, and the y that you have at the end is a very important participant here, and you have to always make sure that you also include it. So you'll have 4x squared. My advice is to just draw the 1 closer to the y. So you multiply the 4 and the y first. It will make this multiplication so much easier, okay, because then you can multiply with 4y instead of multiplying with 4 only, because you will always forget that y needs to be involved in this. Now, in nature of roots, of course, you have to know your theory. If you know your theory on nature of roots, and you understand that delta has to be b squared minus 4ac, and you know what is going on in terms of like the correct substitution of the b value, you remember the square on b. So your b value has to be what you put here. So what you've noticed most of the time is that matrix do not put the b value in brackets. So if you're typing in your calculator -2 squared, you're going to get -4. But if you type -2 in brackets squared, it's going to give you +4. So please do make sure that you're aware of this and you don't make the same mistakes that you've noticed before. We're here to try and help you that these errors and these misconceptions do not actually trouble you. We're still coming back with more. Don't go anywhere. We'll be right back.